Hello everyone. In this session, I will share with you the Laplace transform for derivative to solve the differential equations. This is the theorems of the Laplace transform for derivatives. If the Laplace transform of the yt is equal to ys, then Laplace transform of the y prime t is equal to the sys minus y0. And Laplace transform of the y double prime t is equal to s square ys minus sy0 minus y prime 0, okay, and so on. Now let's look at the example. By using the formula of the Laplace transform, y prime t is equal to sys minus y0. Evaluate the Laplace transform of the sine square t. So in this question, yt is equal to the sine square t, or this is equivalent to sine t squared. Okay, then we differentiate the yt, we get y prime t. Okay, so this means that we differentiate the sine t squared. So this is equivalent to 2 sine t cos t. And from the identity, 2 sine t cos t is equivalent to sine 2t. And then the initial condition, y0 is equal to the sine square 0, and this will equivalent to 0. Then by using the formula, Laplace transform of the y prime t is equal to the sys minus y0. So Laplace transform of the sine 2t is equivalent to sys minus 0. y0 is 0, so you get 0 here. So sine 2t is referred to table of Laplace transform. Sine 2t you get 2 over s squared plus 2 squared equal to sys. Okay, so this one sine 2t you can get from the table of Laplace transform. So now Laplace transform of the sine square t is sys equal to 2 over s squared plus 4. So ys is equal to 2 over s squared plus 4. That's it. Okay. Second question is Laplace transform of t exponent t. In this question, yt is t exponent t, and then we substitute the x0, y0 also equal to 0. And then we differentiate the yt, then what do you obtain? We can use the product rules, so uv prime plus vu prime. Okay, this is assumed as u, this is assumed as v. So u is the t, v prime is exponent t, plus v, okay, v is exponent t, u prime is, you differentiate t, you get 1. Okay. So this means that after I differentiate the yt, I get this result, and this t exponent t also equal to yt, so I rewrite it into yt plus exponent t. So by using the formula, Laplace transform of the y prime t is equal to sys minus y0. So Laplace transform of the yt, so this one I get it from here, Laplace transform of the y prime t, I substitute with the yt plus exponent t. So Laplace transform of the yt plus Laplace transform of the exponent t is equivalent to sys minus 0. Okay, so this, how to get this y0 equal 0? This means that when you substitute the t equal to 0, what do you obtain? So when you substitute t equal to 0, y also 0. This is how you get the y0 equal to 0. So we need this value, and then you substitute in the y0 here. and you get 0. And next, using the formula, so Laplace transform of yt, you get ys plus, and then Laplace transform of the exponent t, you get 1 over s minus 1. So this is from the table of Laplace transform. It's a direct transfer. Okay, equal to sys. So we collect all the ys minus sys. We bring the xys from the to the left, and equal to minus 1 over s minus 1. So ys, I take out the ys, so I left 1 minus s. So at the right hand side, I still have minus 1, s minus 1. So Laplace transform of the t exponent t equal to ys equal to negative 1. So I bring this one to the right hand side. So I have 1 minus s and then s minus 1. So this is equivalent to 1 s minus 1 square. Alternatively, we also can use the method of derivative of transform. Or, okay, we use method of derivative of transform. So if how to solve using method of derivative of transform, okay, we can say Laplace transform of the exponent t is equal to 1 over s minus 1. So this is from the table of Laplace transform. And Laplace transform of the t exponent t is equivalent to minus d over ds Laplace transform of the exponent t. So this is equivalent to d over ds. Okay, and this one, Laplace transform exponent t, we get 1 over s minus 1. Okay, and we differentiate the, okay, we bring up the s minus 1, so easy for the derivative. S minus 1 minus power of minus 1. So then we can differentiate it. So we get minus 1, s minus 1, power of minus 2. Okay, differentiate, you get negative 2. And then we write it properly. Then we get this one cancel out. So we get positive 1. And then s minus 1 power of minus 2, you can bring down, that one become to s minus 1 squared. Okay, next I would like to share with you is to solve the linear differential equation with a constant coefficients using the Laplace transform. Here is a procedure to solve it using this method. So first step is to transform the differential equation become an algebraic equation in ys by finding the Laplace transform for both sides of the differential equation. Then step 2 is to consider the initial conditions. Then step 3 is write the equation in the form of the ys as the only subject of formula. And step 4 is find the solution of yt by evaluating the inverse Laplace transform of the ys. Here, let's look at the example. Solve the following equation using the method of the constant coefficient. Okay, let's look at one by one. The first question is the dy over dt plus y equal to 3 if the initial condition is y0 equal to 0. So the first step is to transform the differential equation for both sides. Okay, this means that from the question, we Laplace transform it. So Laplace transform of the y prime t. So this is referred to the y prime t. Okay, y prime t plus the Laplace transform of the yt equal to Laplace transform of 3. Then y prime t, okay, as you know from the theorems, Laplace transform of the y prime t, you get sys minus y0. Therefore, this one is equal to sys minus y0. And then Laplace transform of the yt, we get ys the Laplace transform of 3, we refer to the table of Laplace transform, you will get 3 over s. So this is the table of Laplace transform in which you have the a here. Okay, we refer to a here. A is equal to a over s. So just now we have a Laplace transform of 3. We get 3 over s. Second step is to consider the initial condition. y0 equal to 0. So we can substitute in the y0 equal to 0 in the equation. So sys and then minus 0 plus with ys equal to 3 over s. Then step 3. We collect all the ys, so ys s plus 1. Okay, this is the ys, this is also ys, so I factor out the ys equal to s plus 1 equal to 3 over s. Then now ys is equal to 3 over s plus 1. And then step number 4 is find the solution yt by evaluating the inverse Laplace transform of the ys. So now inverse Laplace transform of the ys is equal to inverse Laplace transform of 3 over s plus 1. So by using the partial fraction expansion, 3 over s plus 1, we can solve it like split it into a and b. So a divided by s plus b divided by s plus 1. So 3 equal to a. Okay, we bring up this one to the right hand side. So 3 equal to a s plus 1 plus b s. And then we assume the s equal to minus 1. So we get 3 equal to, so this one cancel out. And then we left b. So we have minus 1, so minus b. So b is equal to minus 3. And then we assume the s is equal to 0. Then and a we obtain is 3. Okay. So we can substitute in the value of a and b. So a we get is 3, so means is 3 over s. And then b is minus 3, so minus with inverse Laplace transform of 3 over s plus 1. So yt, we get inverse Laplace transform of 3 over s, we get 3. And inverse Laplace transform of 3 over s plus 1, the 3 is the constant, so we take out the constant. And then 1 over s plus 1 is referred to the exponent minus t. Next, we move to second question. Y double prime minus y prime equal to the exponent t cos t. And the initial condition is y0 equal to 0 and y prime 0 equal to 0. For Laplace transform of y double prime t, we can change to s square ys minus sy0 minus y prime 0. So as mentioned in the table, we have the s square ys minus sy0 minus y prime 0. Okay, so this part is for the y double prime. Okay, then minus with the y prime. Okay, y prime is referred to the sys minus y0 equal to the exponent t cos t. So exponent t cos t is, okay, cos t is equal to the s over s squared plus 1. So this is from the table of Laplace transform. And then we have the exponent t is referred to 1 over s minus 1. So if we combine both, we get s minus 1. Okay, this is for the, we substitute the s with s minus 1. Okay, from here we substitute the s to s minus 1 because of the exponent t here. Alright, so now we can collect the ys. So we have this is the ys, and also this is the ys. So we have the s squared minus s equal to s minus 1 divided by s minus 1 squared plus 1. And then for this part, sy0, because y initial condition, y0 equals 0, so this part will equal 0. And y prime 0 equals 0, so this part will also equal 0. That's why we left the s, this one, and also this one. This one will equal to 0 also. So this is the step 2. Okay, next let's look at the step 3. We move the x squared minus s to the right hand side. So ys is equal to s minus 1 divided by s minus 1 squared plus 1. And then multiply with s squared minus s. So we can multiply in this part. So we have the s squared minus 2s plus 1 plus 1. And then we factor out the s squared minus s, we get s and s minus 1. So we can cancel out this one. So we left 1 over s squared minus 2s plus 2 multiply with s. So this is step 3. And step 4, we inverse Laplace transform of the ys, and then we get inverse Laplace transform of these whole things. So we can solve using the partial fraction expansion. So 1 over s squared minus 2s plus 2 equivalent, or we split it into the a, b, and c. So the first part is a over s plus bs plus c divided by s squared minus 2s plus 2. So we bring this one to the right hand side. So we have 1 equal to a s squared minus 2s plus 2 plus bs plus c multiply with s. So we multiply in everything. So we have a s squared minus 2as plus 2a plus bs squared plus cs. So this is equivalent to a plus b s squared plus c minus 2a s plus 2a. Okay, we collect the s squared, so we get 1a plus b. Then we collect the s, we have a minus 2a and also c. Okay, so now we can compare the coefficient. For the s squared, we have a plus b at the right hand side. Left hand side we have 0. For the s power of 1, we have c minus 2a, and the left hand side we also have 0. And then for the s power of 0, we have 2a for the right hand side, and left hand side we have 1. Okay, we have the value of 1 here. So a is equal to 1 over 2. Okay, we obtain the a equal to 1 over 2. We can substitute in the first equation. So we have a plus b equal to 0, and b is equal to minus 1 over 2. And then we also can substitute into the second equation, c minus 2a equals 0. So c equal to, we substitute the value of a, we get 1. And now we have all the value of a, b, c, and we substitute in the equation. So a is, you obtain a is positive 1 over 2. So inverse Laplace transform of 1 over 2 over s plus b is negative 0.5. So inverse Laplace negative 0.5 s plus c is 1. And then divide by s squared minus 2s plus 2. So inverse Laplace transform, and then we get the yt is equal to, we take out the 0.5 because it's a constant again. So 0.5 inverse Laplace 1 over s, you get 1 plus inverse Laplace transform of this whole things. Okay, how to solve this one? If you still remember, we can factor out this. We can factor out this one. Okay, s squared minus 2s plus 2. So we can factor it out like this: s minus 1 square. Okay, and then plus 1. Because s minus 1 square, we can get is s squared minus 2s plus 1 only. So not enough, then we need to plus another 1. So that is the same value as here. Then what about this one, the top? The top here, how to get the same value? In this question, we have the denominator is s minus 1. So we can add this, use this as one of the solutions. So negative 1 over 2 multiply with s minus 1. Okay, so from here we get negative 1 over 2s plus with 1 over 2. So this plus 1 over 2, what we have is plus 1. So we're not enough. So what I can do here is, okay, negative 1 over 2s plus 1 over 2, so we don't want this, minus 1 over 2, and then plus with 1 here, okay, we plus back this one. So if you solve this one, we will get the same value as this. And next, 0.5 plus with, okay, so from here we know that s minus 1 is referred to the exponent t. Okay, exponent t from the Laplace transform table. And this is also the reason why we want to solve in this way, so that we can transform it using the Laplace transform table. We change s minus 1 to the exponent t. Okay, inverse Laplace transform, and then we left negative 0.5s plus 0.5 divided by s squared plus 1. Now, next is we take out the constant. So we have the constant of negative 1 over 2. The inverse Laplace transform of the s divided by s squared plus 1. So since this is the operation of the plus, so we can split into 2. Okay, inverse Laplace, or take out also the 1 over 2, and left inverse Laplace transform of 1 over s squared plus 1. So this is equivalent to 1 over 2 plus exponent t, and then this one is negative 1 over 2. And inverse Laplace transform of s over s squared plus 1, this is referred to the cos. So cos t plus 1 over 2. This is 1 over s squared plus 1 square. So this is referred to the sin t. Okay, so that's all for this answer. Next, we move to the third question. Dx over dt minus 2y equal to sin t, and dy over dt minus x minus y is equal to 0, and the initial condition is x0 is 0 and y0 is 0. To solve this question, we need to Laplace transform this equation and also this equation. So first of all, I solve this equation first. So dy over dt, minus y minus x minus y equal to 0. So Laplace transform, or Laplace transform for all the equation. So Laplace transform of the dy over dt minus Laplace transform of x and Laplace transform of the y equal to Laplace transform of 0. So Laplace transform of dy over dt I obtain as ys minus y0, and then Laplace transform of the x I obtain xs, and Laplace transform of the y I obtain ys equal to 0. So the initial condition y0 equal to 0. So we know here y0 is 0. So we substitute in the equation. So we obtain sys minus 0 minus xs minus ys equal to 0. So we bring the xs to the another side, and the right hand side. So we have the xs, or we keep the xs to the left and bring another one to the right hand side. So xx equal to sys minus ys. Okay, so bring this one to the right hand side, the left hand side. So we have the xs equal to xys minus ys. So xs is equal to ys, and then s minus 1. We factor it out. Okay, so I assume this equation is equation number 1. I assume this equation is equation number 2. And now we go to another equation, that is dx over dt minus 2y equal to sine t. This is equation number 3. It doesn't matter which equation you want to do it first, so it is the same. So for this equation, I need to Laplace transform the whole equation. So that is a Laplace transform of the dx over dt minus 2 Laplace transform of y equal to Laplace transform of the sine t. So Laplace transform of the dx over dt, we obtain the xs minus x0. Okay. And then minus with 2ys is for this part, equal to Laplace transform of sine t, you get 1 over s squared plus 1. And then we have xs minus 2ys equal to 1 over x squared plus 1, since the x0 is 0. So this one is, I assume, is equation number 4. Okay, now we have 4 equations. Okay, the first one is the dy over dt minus x minus y equal to 0. And the second one is the xs equal to ys multiplied with s minus 1. And equation number 3 is dy over dt minus 2y equal to sine t. And equation number 4 is xs minus 2ys equal to 1 over s squared plus 1. So from here we can see that we have the xs here, in which we can substitute by the value here. So this means that equation number 2 substitute in the equation number 4. So we have the sys s minus 1 minus 2ys equal to 1 over s squared plus 1. So we substitute the xs with the value of this. So we can collect the ys here. So we have x squared minus s. Okay, we collect ys, so this ys. Okay, so we have the x squared minus s minus 2 equal to 1 over s squared plus 1. So ys is equal to 1 over s squared plus 1, and then plus with, and multiply with the s squared minus s minus 2. So this is equivalent to s squared plus 1 multiply with the s plus 1 and then s minus 2. We factor out this one, we become the s plus 1, s minus 2. And now we can using the partial fraction again. So 1 over s squared plus 1 multiply with s plus 1 multiply with s minus 2. We can split into as plus b. We get divide by s squared plus 1 plus c over s plus 1 plus d over s minus 2. So here is 1 equal to, we multiply this one, we move to the right hand side. Okay, so we have the as plus b. We have the s plus 1. We left s plus 1, s minus 2 because the s squared plus 1 can be cancelled out. And then plus c, we can cancel out the s plus 1. So we left c, s squared plus 1, and then s minus 2. And then plus d, we can cancel out the s minus 2, and we left s squared plus 1, s plus 1. Then we assume the s equal to minus 1. Okay, we assume the s equal to minus 1, then what we can get? 1 equal to, okay, if for the s equal to minus 1, okay, this one can be cancelled, equal to 0. Also, this one equal to 0, so we left the c. So c 2 minus 3. So c is equal to negative 1 over 6. Next, we assume the s is equal to 2. So we left 1. So for this part also 0 and this part also 0. So we left the d. So d s equal to 2. So we have the 2 square plus 1. So it's 4 plus 1. And then 2 plus 1 is 3. So here we have the d equal to 1 over 15. And then next we assume the s is equal to 0. Here we have 1 equal to b, 1 minus 2 plus c, 1 negative 2 plus d, 1 and 1. So here we have negative 2b minus 2c plus d, and this is equivalent to negative 2b. We substitute the value of c and d. So we have negative 2b plus 1 over 3 plus 1 over 15. So b is equal to negative 3 over 10. And then we still have the value of a we haven't get. So now we assume the value is s equal to 1. Okay. So we let the s equal to 1. And then we get 1 equal to a plus b, 2 minus 1 plus 2c minus 1 plus d, 2 and 2. So this one you based on the equation here, okay? So now we left negative 2a minus 2b minus 2c plus 4d. So I keep simplifying. Negative 2a minus 2b, b I substitute the value is minus 3 over 10 minus 2c, c is minus 1 over 6 plus d, d is 1 over 15. So I get negative 2a plus 3 over 5 plus 1 over 3 plus 4 over 15. So I left negative 2a plus 1.2. So a is equal to 1 over 10. Now we have all the value. So inverse Laplace transform of the ys is equal to inverse Laplace on everything. So we have inverse Laplace transform. I change the a to 1 over 10 s, and then b is 3 over 10. So this is the first one, s squared. I substitute back all the a, b, and c and d into the equation. So plus minus inverse Laplace transform of b is minus 1 over 6. So I have the minus at the outside here. Okay, and then 1 over 6. This is for the s plus 1. And then d is 1 over 15. This is s minus 2. So inverse Laplace transform of the ys, we get yt. So we take out the constant for the 1 over 10, and then inverse Laplace transform of the s over s squared plus 1. And then we take this one, since we have the operation of minus, so we can split into 2. Also, I take out the constant. We left 1 over s squared plus 1. And then we take out the constant again of 1 over 6, and then inverse 1 over s plus 1. And then we take out the another constant, and we left 1 over s minus 2. So this is equivalent to 1 over 10 s over s squared plus 1. So this is inverse transform of this one. We can get the cos t. And then minus with 3 over 10. And for inverse Laplace on this one, we can get the sin t. And then for this part, inverse Laplace for 1 over s plus 1, we can get exponent t. And then inverse Laplace transform of 1 over s minus 2, we can get exponent 2t. So 1 over 15 exponent 2t. And assume this is the equation number 5. From equation number 1, we have dy over dt minus x minus y equal to 0. And then we can rewrite into x equal to dy over dt minus y. So this I assume is equation number 6. And we differentiate the yt. So this is the yt, right? So we differentiate it. What we get? So dy over dt is equal to, okay, we differentiate the 1 over 10 cos t, we get negative sin t divided by 10. And we differentiate negative 3 over 10 sin t, we get negative 3 over 10 cos t. And we differentiate the 1 over 6 exponent t, we get plus 1 over 6 exponent t. And then we differentiate 1 over 15 exponent 2t, and then we get 2 over 15 exponent 2t. So this I assume is equation number 7. So I substitute the equation 5 and 7 into the equation number 6. This is because equation number 6, we have the dy over dt is actually like this one, minus y is referred to this one, so we obtain x. So therefore, x is equal to dy over dt minus y, where we substitute in all the dy over dt and y. So I get yt equal to minus sine. So this is for the dy over dt. Then minus with the y is negative 10, 1 over 10. Okay, this is equivalent to this one, 2 over 10 sine t minus 4 over 10 cos t. Because this one we can simplify. Okay, it's the sine and also the sine here. So this one we can have the cos, also cos. We left 1 negative 4 over 10 cos t. And then for the exponent t, and we saw this one, so we have plus 2 over 6 exponent negative t. And then for the exponent 2t, we have this 2 over 10, 2 over 15, minus with 1 over 15, we have plus 1 over 15 exponent 2t. So I simplify, I can get 1 over 5 sine t minus 2 over 5 cos t plus 1 over 3 exponent negative t plus 1 over 15 exponent 2t. Okay, that's all for this question. Hope you can understand. If you like my video, you can like my YouTube video. That's all. Thank you.